Hello everyone and welcome back to Exam Ignite YouTube channel. This is Embedded System Design subject of 6th semester of code BEC601. The module 2 we will be discussing about the embedded system design concepts where we'll be covering the characteristics and quality attributes of the embedded system. So here I have prepared the notes by referring to the textbook, and I have prepared this specific page using by referring the model question papers and previous year question papers to note that which question has appeared, which topic has appeared, how many times. Next, the operational and non-operational quality attributes. This was there in the model question paper and June-July 25 question paper. And embedded systems, it's application and domain specific, where we are having the applications like washing machine and automotive domain specific. Then comes the hardware, software co-design and program modeling, where we need to know the hardware software co-designing. They have asked that. And also you need to know the DFG and CDFG that has been asked in the question paper, and also the differences between C versus embedded C, compiler versus cross compiler. Then the state machine model and the sequential program model. In the state machine model, we have vending machine, that is tea or coffee example, and a coin operation telephone system and a seatbelt warning system. These three are the most important questions in this module. You need to know them. And then comes the embedded firmware design and development. You need to know the advantages and disadvantages. So that's all about this module. This module is small, but actually it contains a more application oriented questions where you can expect in the question paper. So we'll move on to the notes. So firstly, the characteristics and the quality attributes of the embedded system is the first topic, where we'll be learning about the characteristics of an embedded system. So embedded system possess specific characteristics with which make them unique from the general purpose computing system. They have a specific characteristics. And then characteristics of an embedded system are what? Application and domain specific. They are reactive and real time, operates even in the harsh environment. They are distributed, small size and weight, and the power concerns. So we will go into the application and domain specific. So embedded systems are designed for performing a specific set of predefined functions only. So developed for a specific function, cannot be used for other purpose, and it is designed for a particular domain. Example is what? A microcontroller woven controller cannot replace the AC controller. Telecom embedded controller cannot be used for consumer electronics, like that. Next is reactive and real time. That is nothing but they interact with the real world through the sensors and input devices, and they react in real time. So respond to the changes in the input variables and events. They produce output according to the input changes, and timing behavior should be deterministic. Example is the flight control system and the anti-lock braking system ABS. Third one is operates in the harsh environment. That is, they are capable of working even under the adverse environmental condition, like even in high temperature, vibration, shock, power supply fluctuations, corrosion, or in the component aging. So the feature is they use high temperature grade components and require short shock absorption techniques. Fourth one is distributed. That is, they may be a part of a large systems where the multiple embedded units work together. So they combine together. So features as they are independent embedded units work together. They perform the overall system function. Example, you can see in an automatic vending machine, there are many parts of embedded units that work together in an ATM machine, etc. Then small size and weight. So these are designed to be compact, lightweight, and portable. So they should be small size, improves the portability, and compact design is preferred in the embedded application. Example is our mobile phone. Then comes sixth one is power concerns. That is an important factor for the designing in the embedded system, where we need to focus on the low power consumption is required. So it reduces the heat generation and improves the battery life. So this uses the low power regulators and power saving processor modes. So this was all about the characteristics of an embedded system. If they ask a question regarding the characteristics, you need to list out the 6 characteristics and explain each of them as given here. Next comes the quality attributes of an embedded system. So what is quality attributes? These are the non-functional requirements that should be addressed during the embedded system. These are not required for functionality but are to be concerned. Classification, we are having two types of quality attributes. One is operational and another one is non-operational. First one is operational quality attributes. That is the response, throughput, reliability, maintainability, security, and safety. Response is nothing but it is a measure of quickness of the system. It is like how fast the system will respond to the input changes that we provide. Then fast response is required in many embedded systems for the quick actions. So delay can affect the system performance. Example in the flight control systems. Throughput. This is means efficiency of the system. This is measured as a rate of production or operation in a given period. So how much it will produce indicates the performance of the system. Example, the card reader, number of transactions per minute or day. Third one is reliability. It is an ability of a system to function properly without failure. So the MTBF means mean time between failures, frequency of the failures. MTTR means mean time to repair, that is time required for repair. Maintainability is nothing but maintainability refers to support and the maintenance of the system during the failures or routine checkup. That is can be scheduled, that is periodic maintenance or the maintenance to unexpected failures. So this is the formula for that where my AI is an availability and MTBF and MTTR is given. Next comes the security. So security deals with the protection of the data and application from the unauthorized access or modification. So means it is about the confidentiality, that is protects the data from the unauthorized disclosure. Then comes the integrity, that is protects the data from the unauthorized modifications. Availability, it protects the data for access. Example is our password protected PDA. Safety, preventing the damage to the operators, public and environment due to the system breakdown or hard hazardous conditions. So what is the features here is it prevents the harmful effects of the failures and handles the hazardous situation safely. So it is important in product engineering. So this is all about the operational quality. Next is comes the non-operational. That is nothing but the quality attributes that are related to the product when it is not in the operational mode. So this is an important question because they have asked in the two model, one is model question paper and in June July question paper. So both the operational and non-operational quality attributes you have to list down and you have to explain them in 2 to 3 points each of them. Next is testability. Here it deals with how easily the design, application and hardware can be tested, like applicable to both the hardware testing and the software testing. So hardware is nothing but peripherals and the hardware function. Software is nothing but software functioning. Next is debug ability. It is a process of debugging the product to identify the probable cause of the unexpected behavior. We are having both again two types, hardware level and software level. Evolvability is nothing but ability of an embedded system to be modified according to the new hardware or new software technology. How can it be modified? Is it flexible enough? Next is portability. It is nothing but the measure of a system independence. Like products should work in a different environments or in the controllers. High level language software is easier to port. Assembly language or what software has poor portability. Next comes the time to prototype and market. That is the time elapsed between the product conceptualization and the product release. This is an important factor in the commercial success. So methods to reduce here is you need to do the product prototyping and reuse the assets of the shelf components. Next comes the per unit cost and revenue. It is a cost is an important factor monitored by both the manufacturer and the end user. It should be nominal and proper market study and the cost benefit analysis the required. Then the budget and system cost should be balanced for the profit. So the product life cycle is nothing but life cycle of an embedded system product for development to retirement. What are the stages it passes through? First, the product is developed, that is design and developing phase, where the investment is done, no returns. Next, product is introduced, it is released to the market, low sales and revenue here. Growth, the sales and the revenue increase rapidly. Finally, the product maturity, where the revenue reaches its maximum level. Then product retirement, where the sales and the revenue will decrease and the product is discontinued. So here revenue increases from introduction to the maturity stage. Profit is a negative during the development stage. Unit cost will decrease with the time. So next comes the next topic, that is embedded system application and the domain specific applications. That is, firstly we'll go with the washing machine. An important question you need to note here, that washing machine is a typical example of an application specific embedded system that is used in the home automation applications. Why? It provides an enhanced features and comfort. It uses embedded controller for the automatic operation and supports different washing functions. Then what are the components of a washing machine embedded system? Firstly, sensors. Why? To detect the parameters like the water temperature or the level sensor. Then actuators to perform the actions like the tumble tub or the water drawing pump or the water inlet valve. Then comes a control unit. It contains a microcontroller or a processor based board. With this will interface the sensors as well as the actuator, processes the sensor data and generates the actuator control signals. User interface, that is the keypad that we are having, or LED or LCD display or the status indicating LEDs. So this shows us the washing time or the selecting the cloth type or configuring the washing stages like that. Then how does this work? For a top loading machine, aggregator twists back and forth, pulls the cloth to bottom of the tub and the cloths return to top and process repeats. This is how it does. In the front load, cloths tumble and move through the water repeatedly. So what are the stages? Wash, spin and rinse. So spin phase, water is pumped out from the inner tub. Tub spins at a high RPM and removes the excess water from the cloth. So what are the user control units that we are having? Options like wash, spin, rinse, light or medium or heavy duty, and the timings to select. So input output interfaces. For the input we are having keypad, temperature sensor and water level. We can give what should be the sensor measurements. Next comes output interfaces. Here we are having LCD or LED display, then status LEDs and the motor control for the aggregator and the tub movement and the water inlet valve. So you have to write this diagram of a washing machine. This is a, here we are given a lever sensor and the inner tub, and this is the outer tub, inlet of the water pipe, and this is the water outlet. It is a overall body case. Here we are having the control panel with the user interface, and you need to mention it separately here. These are the keypad we are having, LED display, that is for the user interface. So finally, the overall washing machine functional block diagram. Next example is automotive. This is a domain-specific example of an embedded system. So embedded systems are used in the vehicles to control the mechanical and electrical systems, right? So it is built around the microcontrollers or the DSPs or a hybrid of both. So hence it is known as an electronic control units. So it is used for safety, comfort, or vehicle control. Example is, so these are all the embedded systems that are we use in a single automotive domain. So what are those? We use an engine control, fuel injection control, fan control, or the headlamp control, ABS control, wiper control, suspension control. Like this, we are having many small embedded systems. So overall, ordinary vehicles contain around 20 to 40 embedded controllers. Luxury vehicles have 100 plus. So first automotive embedded system, so microprocessor based fuel injection system was introduced by the Volkswagen in Volkswagen 1600 in 1968. What is the inner working of this automotive embedded system? So it controls the mechanical and the electrical operations of a vehicle using the ECUs. ECUs is nothing but electronic control units. So what are the features? They control from the simple systems to the complex systems, like it can be a mirror control, wiper control, airbag control, and anti-lock braking system. So again we are having two types of ECUs, on high speed and low speed. High speed means it is used in the critical automotive applications which requires fast response, like the fuel injection or the anti-lock braking system, engine controlling, steering control, transmission control, like that. For the low speed electronic control units means where response time is not critical. So it is built using the low cost or the microcontroller or processor, like the audio controller or the power windows, wiper control or the mirror. These are not that necessary to have a quick response. Next is the automotive communication buses. So Automotive systems use a serial communication bus to reduce the wiring inside the vehicles. We are having again three types. One is controller area network, local interconnected network, and media oriented system transport. So firstly, CAN, it is controller area network. It is a serial communication portal used in the automotive embedded system. So it is an event driven protocol. It supports the error handling and the data rates as given. Where we use here in the airbag, in the powertrain, and engine control in the ABS and GPS navigation systems. Where do we use local interconnect network? It is a single master multiple slave low speed communication interface. It supports up to 16 slave mode single wire communication interface. Data rate is up to 20 kbps. Example is mirror control, fan control, seat positioning, or window or the position controls. The next is media oriented system transport bus. It is a high bandwidth automotive multimedia communication network used for the audio video systems. So uses optical fiber cable and it supports the star topology, ring topology, and daisy chain topology. So multimedia networks in cars. So this was all about the part 1 video of the module 2. So in the part 2, we will be continuing with the hardware, software, co-design, and program modeling. So stay tuned. Do like, share, and subscribe to Exam Ignite. Thank you for watching.